Hello everyone, let's solve the Leetcode problem number 300, longest increasing subsequence. So, what the question says, given an integer array nums, return the length of the longest strictly increasing subsequence. They have mentioned longest strictly increasing subsequence. We have to return, we don't have to return the increasing subsequence, but we have to return the length of the longest strictly increasing subsequence, nothing but the length, right? So in the example 1, we can see 10, 9, 2, 5, 3, they have given the sequence, and the longest strictly increasing subsequence is nothing but 2, 3, 7 and 101. We can clearly see here the length of this one is 4, right? 1, 2, 3, 4. So we have mentioned the same thing. The same thing goes with the example 2 and 3 as well. So let's start writing the code. And after writing the code, I'll just take the example 1 and I'll explain, right? So initially what we'll do, we'll initialize an array called sequence. I'll just take the variable name sequence with the same length as nums filled with ones. We'll fill all the things with, we'll be filling the array with the ones, right? Each element in the sequence represents the length of longest increasing subsequence ending at that index. So let me give let sequence. If I write the code, you'll get to know. While we take example, I'll get to know easily. So this will be nums, length of the nums, right? Length of the nums, and we will be filling this one with ones initially, as I said. Next, what we'll do, we'll iterate over the nums array using the index I. We are having the nums array now filled with the ones. We will be iterating over the nums array using the index I. I'll just make use of the for loop. This is simple. Length of the nums. So this is fine. Next, what we are doing, for each I, check all the previous indices j. Nothing but if this one is 9, if this is I, this one will be j. For each I, check all the previous indices j to find all the valid increasing subsequence. So to find all the valid increasing subsequences, we are checking for each I to check for each I, we are checking all the previous indices to find all the valid increasing subsequences, right? How can we write that? We'll take one more for loop. I'll just give for let j equals I. I minus 1, it has to be, right? We are checking for the previous this one. We are starting at the same index j at this one, but we are checking for the previous number when it comes to j, right? It has to be I minus 1. Sorry, j greater than or equal to, it can be equal to 0 or it can be greater than 0. So j greater than or equal to 0, j minus 1. This is fine. Next, what we'll do, if the value at the index j, if the value at the index j is less than the value at the index I, so this one, j is less than I. Suppose this is I and this is j. If the j, if it is less than the 9, 10 is less than 9. 10 is not less than 9. But in case, just take this example whether we have 7 here. So 7 is less than 9, right? So then we will update the sequence I. Nothing but in this case, we can take as nums of j is less than nums of I. Then what we can do, we will update the length of the longest subsequence, right? Just give me a second. Did I do something wrong? So yeah, if the value at index j is less than the value at index I, we'll be updating the sequence I, right? Nothing but we will update the length of the longest increasing subsequence ending at I by considering what we'll consider the length of the longest ending longest increasing subsequence at the j plus 1 window. Okay, it will start with the 0th index, right? So let me give this one sequence of I. So this will be we'll consider the max of iterated value of the sequence along with this sequence of j. This one plus 1. Why? This starts with the 0th index, right? So this will be plus 1. So next what we will do, finally, the final step is we will return the maximum value from the sequence array. We'll check for every sequence right here. We'll check for every sequence and we'll finally find the maximum value from the sequence array, which will represent the length of the longest increasing subsequence. In our case, for this example, we got 4. We'll take this example and let's see how it works. For now, I'll just return to find the maximum. We can make use of math.max, right? For the sequence, to check every sequence, I'll just make use of the spread operator. I'll just give sequence. So this is fine. Let me format the code and let me hit the submit. So this works absolutely correct. So I'll just come here. Second. So let's consider this one. Example 1. So initially what we are doing, we will create a sequence array initialized to 1. This one, according to this one, what we'll do is create an initialized array to initialize this one, sequence to length. The length we have is here 1, 2, 3, 4, 5, 6, 7, 8 numbers we are having, right? Initially, we'll initialize everything to 1. Nothing but we'll be having 8 ones initially, right? And hit this one. Then, since each element starts from the subsequence of length 1, nothing but we are filling according to this one. Next step will be processing the each element. Let's start with the this one, 10 initially, right? So index 0, this one, 10 we are considering. So no previous element is found. We are not having any previous element according to this one. This is the first number, right, at the index 0. So no previous element is found to compare. So sequence of 0 will be initially, this will be 1. So let me consider here, sequence of 0 will be initially 1. So let's come to the index 1 now, this one, 9. So let me consider this one, 9. We are going to the 9, right? So we are comparing 10. So no update, because we will come here and we will check whether 9 is less than, just give me a second. 9 is less than 10. So 9 is less than 10. So the sequence of 1 will be still 1 itself, right? The second step also, the sequence of 1 will be 1 itself. We will come to index 3 here, the third one. Third one, what we will do, we'll be comparing the 10 and 9, right? So sorry, just give me a second here. 9 and 10 will get the sequence too. This one will be comparing 10 and 9, right? So 10 and 9, no update will be finding no update, because sequence of 2 will also be 1. 10 is not less than 9, right? So we'll come to the index 3, 5. This one we will be considering. So this time we'll compare 10, 9 and 2. Why we are considering 10, 9 and 2? Because we have moved to this one. Which one now? 2, 3. 4th index, right? Just give me a second. Index 3 or 4? This one we have come to the index 3. Sorry. That one. Index 5, right? So now we are not considering 3 basically. We are considering 5. We are comparing with 10, 9 and 2. We'll update the sequence of 3 equals 2. This step. 1, 1, 2. Now we are updating this one to 2. Next, we will go for the index 4. This one, 3. Now, we'll compare 10, 9, 2 and 5. We'll compare with 10, 9, 2 and 5. These 4 things, right? We'll compare with 10, 9, 2 and 5. So, we'll update the sequence of 4 equals 2, because 3 is greater than 2, right? Now, the sequence of 4 is 2. And, the sequence of 4 is 2. Sorry. Now we'll come to the index 5, 7, this one. We will compare all the previous elements, nothing but while we come to 7, we'll be comparing 7 with this one, 10, 9, 2, 5 and 3. We'll be comparing with all the previous elements and we'll update the sequence of 5 to 3. Why we'll update the sequence of 5 to 3? Because 7 is greater than 5. This one, the least one. 7 is greater than 5. Next, we'll come to index 6, nothing but 101. This one we will be considering. 7 we already considered, we'll be considering 101. 101 will be comparing with the previous elements, right? All the previous elements will compare 101 with all the previous elements. Now the sequence of 6 will be 4. Why the sequence of this one will be 4? Because 101 is greater than 7. You can clearly see here 101 is greater than 7. So next we will come to the last one, last index, nothing but the 7th index, this one, 18, right? So we will compare 18 with all the previous elements and we will update the sequence of 7 to 4 itself. Why? Because 18 is not less than 101, right? But 18 is greater than 7. So the length will be 4 itself. So the length will be 4 itself, but 18 is greater than 7. So the maximum value in the sequence array is, we know that now it is 4, which is the length of the longest increasing subsequence, nothing but 2, 3, 4, 2, 3, 7, right? This has to be 7. 2, 3, 7 and 101. So that's what they have given here. The longest increasing subsequence is 2, 3, 7 and 101. Therefore, the length is 4. The length we got here is 4 for this, right? So what we can conclude here, we are the function is calculating the longest increasing subsequence by updating the lengths, right? As it processes each element. We are processing each element, which is resulting in the length of 4. We got the result length finally, the 4 for the longest subsequence, this one, 2, 3, 7 and 101. We clearly saw with this example, right? So this is fair. Let me delete this one. So what would be the time complexity and the space complexity? The time complexity would be big of n to the power of 2. Why big of n to the power of 2? Because we are making use of the nested loops here. And the space complexity would be big of n. Why the space complexity would be big of n? Because we are making use of the sequence array to store the elements, right? So the overall time complexity and the space complexity would be, the time complexity would be big of n to the power of 2. So here it would be big of n to the power of 2 and the space complexity would be big of n. So let me comment this. So yeah, let me hit the submit. So this works absolutely fine. So this is it. Thanks for watching, guys.